Welcome to our next video about three-dimensional vectors. Today we're going to be discussing dot products of three-dimensional vectors. If you recall, a dot product of a two-dimensional vector, let's say you have vector u equals 1, 3, and vector v equals 5, 7. To calculate the dot product, you would multiply your x components, so 1 times 5. Then you multiply your y components, 3 times 7, and then you calculate the sum. So this would be 5 plus 21, which is 26. A dot product is a scalar, meaning that it's just a number. It's not a vector. The dot product of A and B, this time A and B being 3D vectors, meaning that they have the x, the y, and the z component, is found by multiplying your x components, multiplying your y components, multiplying your z components, and then finding the sum. And another thing to note, just like with 2D vectors, in three-dimensional vectors, vectors are orthogonal if their dot product equals 0. And orthogonal is just a really fancy way of saying perpendicular. So let's do an example or two. This first one says, find the dot product of u and v if u is this and v is this. And again, it might be nice to have a calculator handy for this. Sometimes the mathematics ends up making pretty large numbers. -1 and -3. I like to write them like this because I can just multiply down the columns. So -1 times 3, that's -3. 6 times -1 is -6. And then 3 times 3 is +9. And then you are adding all of these things up. So this actually ends up being -3 plus -6, which is -9, plus +9, which is 0. So the dot product of these two vectors is 0. Since the dot product is 0, then you have orthogonal vectors. If we had gotten any number besides 0, we would not be orthogonal. Another way of thinking about it is find a vector that is orthogonal to this vector. Now it is kind of important to note that there are an infinite number of orthogonal vectors to this vector. It doesn't really matter what the numbers are unless you're given a specific dimension or magnitude that you're going for. So what I like to do is kind of think about it like this. I have vector for -5 and -6 times a variable vector. You can call it XYZ or ABC, whichever you prefer. And technically this shouldn't have commas, or this should have a little bit neater commas in it. And you want to equal 0 because the dot product of orthogonal vectors is always 0. So you can kind of create like an equation for yourself. You have 4 times x plus -5 times y plus, oh, this was a +6, 6 times z has to equal 0. So any three numbers that you pick have to make this statement true. So you can see how you have an infinite number of answers. What a lot of people like to do is go for ones. So if you have 4 and then -5 and 6, you could do 1/4, and you could do 1/5, so that's 1 minus 1. And then for your last one, you could just make it be 0. That in turn gives you 0. Technically that's plus 6. That in turn gives you 0. So you can say that this vector would be orthogonal. 1/4, 1/5, and 0. Or you could try to get a little bit fancier. You have 4 and -5 and +6. You could just pick your favorite numbers. So 4 times 4 is 16. 5 times 4 is 20. So you've got 16 minus 20. And then you need another number to fill in here. That would make it be 0. And you can pick whatever number you want. That would make the true statement. So right now you're at -4. So you would need to multiply 6 by something that would give you -4. Which would end up being 2/3. So another potential answer would be 4 and 4 and 2/3. Now, one thing that will not work, which is not allowed, is to use a 0 vector. So a vector that's 0, 0, 0. Just because it's almost like cheating. You need to try to come up with a vector that has a magnitude bigger than 0. This is all we have for our video about dot products of 3D vectors. Feel free to review and go back and rewatch anything. And as always, make good choices.